Today we are going to review some exponent rules. So the first rule is that we have two things of the same base, we can add their powers. It's called the product rule. So for example, if I have 5 to the third power times 5 to the second power, their bases are the same, so I can add their exponents, which makes me 5 to the fifth. And if you don't believe that, you can draw it out. 5 to the third means 5 3 times. So 5 times 5 times 5 times 5 squared means 5 2 times. And all together here, it's 5 to the fifth power. Another rule is that if you have a negative exponent, you have to cross the fraction bar and move it to the bottom. So for example, if I have 6 to the negative third power, I send the 6 to the bottom. So this is a fraction really over 1. And so since it's negative in the top, you have to cross the bar and make it positive in the bottom. So it becomes 1 over 6 to the third. Similarly, if I have 1 over 2 to the negative third power, it's negative in the bottom, so you have to cross the fraction bar, move it to the top, and it becomes positive, so 2 to the third. And if you want to write over 1, you can. So let's try this. So letter A, that power is negative, so I'm going to take the 4 and send it to the bottom. You just put the 1 on the top of the fraction as a placeholder, and the 4, when it goes to the bottom, that power becomes a positive. 1 over 4 squared is 16. Letter B is a little bit different because I have a negative out front. And this power right here is only on my only on my 4. It's not on my negative. So let me rewrite this as negative 1 times 4 to the negative 2 power. And then it's just the 4 that goes down to the bottom because its exponent is negative. So my negative 1 stays in the top. It does not have a negative exponent, but the 4 goes down to the bottom and the power becomes a positive. And then I have negative 1 over 4 squared is 16. Letter C, first of all, when you have a fraction and they have a power outside, they both get the power. So I get 2 to the negative third over 5 to the negative third. They both have negative powers, so I need to flip-flop them. So the 5 comes to the top and its power becomes a positive. The 2 goes to the bottom, and then its power becomes a positive. 5 to the third, 5 times 5 is 25. Times 5 more is 125. 2 times 2 is 4. Times 2 is 8. So I get 125 over 8. Letter D, similar to letter C, everyone in those parentheses, whether it's a fraction or not a fraction, everyone needs that power. So I get x to the negative 3 power, y to the negative 3 power. They both have negative powers, so I need to send them down to the denominator. So 1 on the top of the fraction to hold my place. When x goes down to the bottom, its power becomes positive. When y goes down to the bottom, its power becomes a positive. Letter E, little tricky. The x, I'll zoom in for you. The x has a power of 1 right here. There's no other power on it, just a 1, a hiding little 1. The x doesn't have a negative power, though. It's just an x with a 1 power, so the x gets to stay up top. But the y has a negative power, so I need to send him to the bottom, and then when he crosses that fraction bar, his power becomes a positive. Okay, so some more exponent rules. Similar to when we were multiplying, we would add the powers. And the reason I remember that is multiplying makes things bigger, adding makes things bigger. When we divide, as long as we have the same base, we can subtract the powers. So let me give you an example. Let's say I had 2 to the fifth over 2 to the third. Because the bases are the same, the 2's, we can subtract 5 minus 3 and get 2 to the second power. I like to draw these out sometimes when you're stuck. So on top I have 5 2's, 2 times 2 times 2 times 2 times 2 over on the bottom, 2, 2, and 2, 3 times. These cancel out, these cancel out, these cancel out. You are left with right here this, which is the same thing as 2 squared, or 4. So let's try that on these examples. If you need to draw them out, by all means, go ahead and pause the video and draw them out. But I'm just going to rewrite this as 12. I subtract. It's always the top minus the bottom. So 5 minus 2. 5 minus 2 is 3, so I get 12 to the 3rd power. The next one, again, top minus bottom. So be careful with your negative sign. So on the top, I have a to the 5th minus negative 8. 5 minus a negative makes it a plus. This is really 5 plus 8, which is going to be a to the 13th. I think I enjoy exponents because there's more than one way to look at it. You could have also done this one by doing this. You get a to the 5th in top. The 8 is a negative power on the bottom, so you get to move it up to the top. And then this is the rule from the front page, where it's 5 plus 8, which is what we ended up doing right there. So either way is right. On letter C, okay, let me box these really quick. Box my answers. So in letter C, I'm going to do it piece by piece. The 16 stays where it is, does not have a negative power. My 12 stays where it is, doesn't have a negative power. My m to the 11th stays, does not have a negative power. But my m to the 9th has a negative power. So you can do it like this. Just because we're doing exponent rules, please don't abandon all the math you know. You can type in a calculator, or you can reduce these two right here. They both have a 4 in common. 4 goes into 16 4 times. 4 goes into 12 3 times. So this reduces to 4/3. And then I get to add these two because they're next to each other. So it's going to make m to the 20th. So let's put it all back together. 4 on top, 3 on the bottom, m to the 20th in the bottom. Okay, I'm going to do my numbers first on the next one. 25, and I went with the R. Try a highlighter instead. Do my numbers first. So 25 and 10 both have a 5 in common. 5 goes into 25 5 times. 5 goes into 10 2 times. So I know I'm going to have a 5 and a 2. I'm going to subtract. So if I do R 7, always top minus bottom, 7 minus 9, you get R to the negative 2. Because it's negative, we're going to put it in the bottom and make it R squared. With the z's, however, I'm going to do z to the 5th minus 1, because there's just hiding one power right there, and get z to the 4th. Because that power is positive, it's going to stay in the top. So let's write it out. 5 on top, 2 on bottom. The r's go on the bottom. It's r squared on the bottom, and the z went to the top, z to the 7th. Okay, let's try some more. Let's try putting all of it together. So the first thing I'm going to do is PEMDAS, and I'm going to handle the parentheses. Excuse me, I'm sorry. Everyone in here gets this power. So out front, my 3x to the negative 2 doesn't go anywhere. When you do 4 to the negative 1 raised to the 2nd power, you have to multiply these two numbers together. So you're going to get 4 to the negative 2. So down here, I'm going to put times 4 to the negative 2. And then the same idea with your x's. I'm going to have x to the negative 5th squared, which is going to get me x to the negative 10th, because I multiply those two powers. So I get x to the negative 10th. So now when I put all of this back together, I'm going to get a bit of a fraction bar. I'm just going to move things. I like dealing with the negative exponents first. The 3 was positive exponent, stays on top. The x squared goes to the bottom. The 4 had a negative exponent, it goes to the bottom. The x to the 10th had a negative exponent, it goes to the bottom. And then I can just clean this up one more time. We always write numbers first in math, so 3 on top, 4 squared is 16. I'll cross them if I deal with them. On the bottom, you have to add those two. So 2 plus 10 is x to the 12th power. Okay, let's try the next one. So I like to move everything first. It's just my personal preference. So 8 and 12 don't go anywhere. 8 and 12. P to the third has a positive exponent, gets to stay. Q to the first needs to go on the bottom. P squared needs to get moved up top. And this Q right here was already positive, so it gets to stay in the bottom. So when I clean it up, I get 4 goes into 12 3 times, 4 goes into 8 2 times. So I'm going to get 3 over 2. On top, I have 1, 2, 3, 4, 5. I added those two. P to the fifth. On the bottom, there's a 1 here, so Q and a Q make a Q squared. So here's letter A. Here's letter B. And let's do letter C. Letter C's got piece by piece. So I'm going to deal with all of these exponents out here first. All of those ones. So I get 3 to the negative 1, x to the negative 2, because I multiplied these two together. That's the first one. Then I get 3 to the negative 2. This negative 2 power is going to go to everyone. X to the negative 10th. On bottom, I'm going to get a 3 to the negative 2 because I multiplied the negative 1 and the 2 together. And then x to the negative 4th. Because I have so many things right now that are negative and positive, I'm just going to move everything to the side of the fraction that it should be on to make my life easier. So, let's see. This 3 we'll do in green. That 3 needs to go to the bottom, 3 to the first. This one needs to go to the top because now it's going to be positive. This one, oops, sorry. Not that one. This 3 right here needs to go to the top. Sorry, it's in the top. It needs to go to the bottom because it had a negative exponent. Now with my x's, both of these two x's are going to the bottom. So x squared in the bottom, x to the 10th in the bottom, and this one goes up top. Okay, now I have everyone where it belongs. Now we can clean things up a little bit. 3 squared and 3 squared get to cancel out. So on top, I'm going to have x to the 4th, and on bottom I have 3x to the 12th. And then remember, we subtract these two. X to the 4th minus 12 is going to be x to the negative 8, so that needs to go on the bottom to be a positive. So my final answer should be 1 as a placeholder on top. You can't put nothing on the top of your fraction over 3x to the 8th. Okay. At some point in time, just want a little review, you learned a rule. If I have a to the p over r power, that's a to the something power over the something root. So if I have a to the 2/3 power, that means the power on a is 2, it's a squared, but I'm going to take the third or the cubed root, where this is my power, and this out here is my root. So with that in our minds, now we can talk about this box right here. If we take an even root of something, then it can be, in theory, a positive or a negative. But when we take an odd root of something, it is the value, or sorry, it is the sign of that number. So, for example, if I take the cubed root of -8, that means something 3 times is -8. Since the 8 is negative, all of these somethings have to be negative, and the cubed root of 8 is 2. So -2 times -2 times -2. So I took an odd root of a negative, and my answer was negative. So let's try this. So I find it most helpful if you rewrite the powers first. So for example, this is the first power over the second root, or the square root. This is the same thing as 36 to the first power, and if you need to write the 2 for second root, you can. The square root of 36 is 6. There was no plus or minus in the front of this, so we only take what's called the principal or the positive root. On the next one, this is similar to what we did on the other page. I'm going to pull the -1 out. It doesn't have a power on it. And then I have 100 to the 1/2 power. So my -1 chills out front, but I rewrite that 100 as a 100 to the first power with the second root. Well, the square root of 100 is 10 times my -1, so I get -10. On letter C, they already pulled the negative out for me, so I got a negative out front, and then in my parentheses, I'm going to do power over root, so 225 to the first power square root. Square root of 225 is 15, so this is going to be -15. Okay, and then this last one, I'm going to do up here because I have this blue down here. So this one is 625 to the first power, but this time I want the fourth root. So if you take the square root of 225, 25 times 25 is 625, which means 5 times 5 times 5 times 5 is 625. And so what I really have right now is the fourth root of 5 to the 5th. Oh, no, sorry, 5 to the 4th power, because I had 4 of them. 1, 2, 3, 4. The fourth root and the fourth power undo each other. It's like saying 5 to the 4th power over the fourth root. Well, 4 divided by 4 is 1. 5 to the first is just a 5. This next answer is a tricky one. And I'm going to tell you it's not possible, and then I'm going to show you why. What this problem says is take some negative power and fourth root it, which means 1, 2, 3, 4. A times A times A times A, whatever that A is, has to equal -1,296. Well, here's the problem. If I tell you that A is a negative times a negative times a negative times a negative times a negative make a positive, a negative times a negative make a positive and a positive multiplied make a positive. There's no way I could make this. If I try that again with with positives, a positive times a positive times a positive times a positive. These are a positive when multiplied. Positive when multiplied, these are a positive. I'm still going to equal a positive. I'm never going to get this negative sign. So that one is not possible. Letter F is similar to letter B, where I've got to pull that negative out. So you pull the -1 out, and then you do 1,296 to the 1/4 power, which is -1 times 1,296 fourth rooted. You can use a calculator for that, and you should get the answer is 6. And then I drop my negative down, so I get -6. So the answer to this problem is -6. Don't think that letter G is not possible. Letter G is possible because the root I am taking out here is an odd root. So I'm going to do negative 27, because it's inside the parentheses. The whole thing is to the first power, third root. So what times what times what is 27? Well, that's 3 times 3 times 3. And all of them are going to be a negative, because a negative times a negative is a positive, times a negative makes me a negative. My answer is negative 3. Be careful with letter H. You can look at letter H in a couple different ways. I want to pull the negative out like we have, and then I'm going to do the fifth root of 32. The fifth root of 32 is 2. 2 times 2 is 4. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's 2. Then you have to drop down that negative, negative 2. So we're going to stay with the same concept, and we're going to combine it with some stuff. So let's try the next set of problems. So on letter A in example 5, I'm going to do this power over root thing still. I'm going to do one, oops, it's not what I wanted. I want the pen. I did 125. It's to the second power, and it's the cubed root. The beauty about powers and roots is that really it doesn't matter which one you do first. So I like to make things smaller first. I like to take the cubed root of 125, and then I can square it. So the cubed root of 125 is 5, and then I have to square it, and I get 25 as my answer. For B, I'm going to do the same idea. So I'm going to do 32. It's the fifth root of 32, but then I'm going to take this whole thing and raise it to the seventh power. The fifth root of 32 is 2, and then we raise that to the seventh. So 2 times 2 times 2 times 2, hang on, 4 times 4, 16, that's only 3, it's only 4 2s, I need 3 more, times 2, times 2 times 2, 32, 64, 128. Letter C is a little bit trickier, just a little bit. Pull that negative 1 out. Then do the 81 to the 3 halves power. So negative 1, 81, square rooted, and then cube it. So negative 1, square root of 81 is 9, and then cube it. So you have negative 9 cubed. 9 cubed is 729. So negative 729. Letter D is different than letter C because the negative's on the inside. So if I do this, I have to keep that negative because there's parentheses holding it together. So I'm going to do negative 27, cubed root first. Then I'm going to square it. So the cubed root of negative 27 is negative 3, and then I square that. Gets me 9. Letter E, they're so tricky. Letter E, there's a negative on the power, so don't forget your rules. If the power is negative, you drop that thing with the power to the other side of the fraction bar or pull it up to make it become a positive. And once I do that, I can just do what I've been doing, 1 over 16. I want to take the fourth root of 16, and then I want to cube it. So the fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. And then I need to cube that. So I have 1 over 8. Okay, the last one is, I'm going to take the square root of negative 4, and then I'm going to raise it to the 5th power. Unless you want your little friend from Algebra 2I to come back, we don't square root negative numbers, so this is not possible. So on the bottom of this page is a summary of all the rules we've done, listed out separately, but we've used them in different ways in different problems. So let's try using them. Okay, so letter A. Letter A might look a little scary. And It's really not that bad, I swear. We're going to add powers together. Since these have the same bases, I'm going to do the 1/3 plus 5/3. So it's 27 to the 1/3 plus 5/3. Well, that's going to get me 6/3, which is just 2. So on the top, what I really have is 27 squared over 27 cubed. Now we subtract these powers because they have the same bases. So 27 to the 2 minus 3 is 27 to the negative first power. And we don't like negative powers, so we drop it to the other side of the fraction. So this really is on the top of the fraction. So I just move that 27 to the bottom. If you want to write the little 1 power here, you can, but 27 to the first power is just 27. Letter B. Let's simplify letter B. So we're doing piece by piece first. So let's do this one first. So I'm going to do 81, the 4th root of 81. I'm going to raise it to the 5th power. 3 times 3 is 9. 3 times 3 is 9. So 3 times 3 times 3 times 3, 4 3s, is 81. So this is 3 to the 5th. This piece over here, the power is negative, so it's going to become 1 over 4 to the 3 halves, which is the same thing as 1 over, I want to do the square root of 4, and then I want to raise it to the 3rd power. The square root of 4 is 2, so this is 1 over 2 to the 3rd power. So let's put it back together. This was in the top, this is in the bottom, because it's a fraction, because when I multiply these together, I have 3 to the 5th times 1 over 2 to the 3rd. So when I do this, I get on top 3 to the 5th over 2 to the 3rd. 3 to the 5th is 243. 2 to the 3rd is 8. I'm going to do letter E first, a little bit out of order. So just one little trip down memory lane, little trip. If I had 6 times x minus 2, you would distribute that in. So I'm going to do the same thing. I'm going to distribute this in. So I'm going to get m to the 2/3 times m to the 7/3 plus m to the 2/3 times 2m to the 3rd. These two powers we add, so we have m to the 2/3 plus 7/3 plus, I'm going to rewrite this because we put numbers first, 2m to the 2/3 plus 1/3. So this is really m. 2 plus 7 is 9, so I have m to the 9/3 plus 2m to the 3/3. 9 divided by 3 is 3, so I have m cubed plus 2. 3 divided by 3 is 1, so 2m. Okay, let's try the next one. Everyone has to get the powers. So let's do the powers first. So I get 3 squared m. You're going to do 2 times 5 over 6. So you're going to get m to the 10/6. I'll simplify everything in a second. Over y to the 6/4, because I did 2 times 3 over 4, so 6 over 4, times 8 to the 2/3, y, 3 times 2/3 is 6/3, over m to the 12/3, because I did 6 times 2 over 3. Okay, let's clean some stuff up. So piece by piece. This right here is a 9. This right here is really simplifies by 2, so 5/3. This is really divided by 2, so 3 halves. This is really a 2. This is really a 4. And then this is the cubed root of 8 and then squared. Well, the cubed root of 8 is 2 and 2 squared is 4. So on top, from blue I have 9 times my yellow 4. I have m to the 5/3 on top, and I have y squared on top. On bottom, I have y to the 3/2. And then I have m to the 4th. I'm just going to shrink it. I need to clean everything up. So when I multiply those two numbers together, I get 30. Ooh, that's not what I wanted. When I multiply the two numbers together, I'm going to get a 36 on top. I'm going to subtract the m's. When you do 5/3 minus 4, we can change that 4 into 12/3. I get negative 7/3, so on top I have m to the negative 7/3. And the y's, I'm going to do 2 minus 3/2, which is a half. And then you get y to the 1/2. So now, last time I just need to move the negative exponent. 36 stays on top, y to the 1/2 stays on top. But the m to the 7/2 has to move, 7/3. What, 7/2? 7/3 needs to move to the bottom. Okay, on these next ones, they want you to factor, and I guess the trick here is the least power. So remember, on a number line, -5 is actually smaller than -4 or -3. So take out the least power. So we're going to pull out a GCF first. 12 and 8 both have a 4 in common. Least power. So go to the smaller number with a power, the -3. I'm going to pull out an x to the -3. 12 divided by 4 is 3. I'm going to deal with the x in a second. And then 8 divided by 4 is 2. Now, over here, hang on, so you believe me, I pulled out an x to the -3rd. So x to the -2 divided by, because when you pull something out, you're dividing it, x to the -3. That's the same thing as x to the -2 minus -3. That's the same thing as x minus 2 plus 3. That's an x. So there's an x here. Minus, I pulled out x to the -3. So x to the -3 divided by x to the -3. That's just a 1. So there's no x here. So you factor it out, and that's your answer. Let's try again, because that was just a little bit tricky. So on the next one, they don't have a number in common. 4 and 3 don't have a number in common. The smaller thing between a half and 3/2 is a half. So I'm going to pull out an m to the 1/2. That leaves me with a 4 plus 3. M to the 3/2 divided by m to a 1/2 is m to the 3/2 minus a 1/2. That's m to the 1st. So this is just an m. By pulling out the least, we can see that our things inside the parentheses become nice and pretty. Okay, the next one's even trickier, but we got this. Okay, the thing they have in common, both of these two things, is a y minus 2. So I'm going to pull out a y minus 2. Now, the trick in this problem is to pull out the power that is the least. Well, -1/3 is smaller than 2/3. So I'm going to pull out a -1/3. In this first thing, I'm left with a 1 plus. I'm going to call this thing an a for a second. Just call it an a. So if I had a to the 2/3 and I divide it out in a to the -1/3, you get to do a to the 2/3 minus -1/3. That's just an a to the 1st. So plus y minus 2 to the 1st. So I can write this one more time nice and pretty. This is y minus 2 to the negative 1/3 power. This doesn't need the power anymore, so I can combine the 1 and minus 2 and just call this piece y minus 1.